We're going to start out with problem number 1 here, and you have this reaction. The question is, find the standard reduction potential for this at 25 degrees. We remember that E0 is equal to E0 cathode, which is where reduction takes place, minus the E0 of the anode, which is where the oxidation takes place. So if we look at this, we see that O2 plus 4H plus goes to form 2H2O. Now, this has an oxidation number of 0. This has an oxidation number of -2. So you have, for this to occur, you have to add 4 electrons here. And if you gain electrons, that's reduction. And reduction occurs at the cathode. So if you look up the E0 for that, you get 1.224. The other reaction is 4Br minus goes to form 2Br2. And for that to occur, it has to lose 4 electrons, 1 for each bromine. And this is the oxidation step. And the oxidation step occurs at the anode. And if we look that up, that is 1.0873. So minus 1.083. So this is 1.224, and this is 1.0873. So if you do the math here, you get 0.1417 volts. And this is positive, and therefore this reaction would be spontaneous, although I didn't ask that. So that's problem number 1. Problem number 2 asks you to balance 2 equations. The first equation is HC00H, which is just one way to write acetic acid, not acetic acid, methanoic acid, sorry, plus MnO4 minus goes to form CO2 plus Mn2 plus. So you have 2 half reactions here. We're going to do this by half reactions. The first half reaction is HC00H goes to form CO2 plus 2H plus. CO2 plus 2H plus. Now in order to do that, we have to calculate which one of these changes its oxidation number. This is -2, this is -2, this is +1, this is +1. So that means this has to be +2 for this to be 0 overall. And this has to be +4. So for this to occur, we have to have 2 electrons come off here. So this is the oxidation step. Then we have MnO4 minus goes to form Mn2 plus 4H2O plus 8H plus. Okay, so the first step here, so this goes from, this is a total of -8, 4 times a -2. Subtract 1 from that because it has a minus sign, so -7, so this has to be +7 going to +2. In order to do that, you have to add 5 electrons. So this is the reduction step. Now, in order for this reaction to occur, in order to balance these, you have to multiply this bottom one by 2 and this top one by 5 for the electrons to cancel out. And if you do that, you get 2 times 8 is 16 H plus 5 times this, so 5HCOOH, plus 2 times this, so that's 2MnO4 minus. All this goes to form 5CO2 plus 10H plus, that's 5 times 2 is 10, and 2 plus 2Mn2 plus 8 H2O. And then you have H's on both sides, so this can simplify to 6H plus 5HCOOH plus 2MnO4 minus, goes to form 5CO2 plus 2Mn plus 2 plus 8 H2O. Now to check, this is the final answer. To check this answer, you can look at oxygen. So 5 times 2 is 10 oxygens here. 2 times is 8 here, so that's a total of 18. 5 times 2 is 10. 8 times this is 8, so you have 18 oxygens on both sides. You can also check the hydrogens. 5 times 2 is 10, and 6 on this side. And then on this side, you have 8 times 2 is 16, so 16 and 16. So everything's balanced. So this is the answer right here. So that's the first one. The second one, you have Cr3 plus Br2 goes to form CrO4 minus plus Br minus. Okay? Now, I know that in the book this is -2, but for the purposes of this exercise, you don't have to fix that. You should do it just as it's written here. Here you have a +7 oxidation number. It's +4 here, so you have Cr3 plus goes to form CrO4 minus plus, to go from 3 to 7 is 4 electrons, losing 4 electrons. Plus, now balancing the oxygens, you have to have 4 H2O on this side and 8 H plus on this side. Then for this one, you have Br2 plus 2 electrons goes to form 2 Br minus. Now, in order for the electrons to balance, you have to multiply this bottom one by 2. So you have 4 H2O plus Cr2 plus, or 3 plus, excuse me, plus 2 Br2 goes to form CrO4 minus plus 4 Br minus plus 8 H plus. Again, you can check this by looking at oxygen, they're balanced, hydrogens, they're balanced, you have everything's balanced, and on top of that, your electrons are balanced. So there's the answer to the second one.